Writing a model means to take the words and translate them to algebra. There are three parts to a model: decision variables, the number of items being made or sold; keywords, how much, how many. X1 is the first one and X2 is the second one. In the first few weeks, we'll be using just two X values. In later weeks, we will have three or more decision variables. These are what we will be solving for. Objective function, this will either be maximize profit, maximize revenue, or to minimize cost. Maximize or minimize will be the key word to look for. Constraints. These are the restrictions on the problem. For example, a company that makes jeans might have a limited supply of hours that the machines can run, or a limited daily supply of fabric. Another example might be a dietitian that's making a meal plan for someone, and the dietitian suggests at least one serving per day of fruit. Okay, here's an example. A company makes two products, 1 and 2, that require a certain amount of labor and a certain amount of cloth. They want to know how many of each product to make in order to maximize profit. Okay, how many to make of each product tells us our decision variables. And when we look at our table, product 1, each of product 1 requires 1 hour of labor, 4 yards of cloth, and makes a profit of $20. Product 2 requires 2 hours of labor, 3 yards of cloth, and $30 is made for each one. There are 14 hours per day and 36 yards of cloth. So our model formation, X1 is the number of product 1, X2 is the number of product 2. Our objective function, we use Z equals for that. If each of product 1 makes $20, then the total profit from product 1 is 20 times the number of product 1. Product 1 is represented by X1. If each of product 2 makes $30, then the total profit from product 1 is 30 times the number of product 2. Product 2 is X2. So the total profit, Z equals 20 times X1 plus 30 times X2. The constraints are the limited labor and cloth. Labor is used to make product 1 and product 2. The amount of labor needed for X1 is 1 hour. So the amount of labor needed for X2 is 2 hours. So the total amount of labor is 1 hour times however many of X1 are made, plus 2 hours times however many of X2 is made. So the total labor is 1X1 plus 2X2. The total labor must be less than or equal to 14. Cloth is used to make product 1 and product 2. The cloth needed for each X1 is 4 yards. The cloth needed for each X2 is 3 yards. The total amount of cloth used is 4 yards times however many of X1 are made, plus 3 yards times however many of X2 is made. So the total yards is 4X1 plus 3X2, 4 times the number made plus 3 times the number made. Total yards must be less than or equal to 36 because that's how many are available. So our yards constraint is 4X1 plus 3X2 less than or equal to 36. A non-negative constraint, since X1 and X2 represent products being made, they cannot be negative. You cannot make -5 pairs of jeans. So X1 and X2 are greater than or equal to 0. And there we have our full model summary, decision variables, the number of product 1 and product 2, maximize profit, and our 3 constraints, our labor, our cloth, and that X1 and X2 have to be 0 or more. They can't be negative. And that is the end of creating the model. In another video, we will solve it.